Hello, ladies and gentlemen. Today we are going to be starting on a new unit. We're going to start with finding some angle measurements in polygons before we get into some area formulas and things like that. So you're going to need your notes for this. You're going to also want a calculator. We're going to be doing quite a bit of calculating today, as well as something to write with, obviously. I have guided notes for this lesson, so if you have those already into your notebook, you can just sort of follow along and add in things as we go. And it makes, obviously, your note-taking quite a bit easier. All right, let's go ahead and jump right in. We're going to start with some review ideas first, or concepts. You may have seen these words before. In fact, I'm pretty sure you have, but I wanted to make sure we were all clear on these two words before we get started. There are different types of categories for shapes in the world. There's concave and there's convex polygons. And so concave versus convex, what does that look like? And if you remember this idea of concave versus convex, you may remember that this is when we're talking about whether shapes sort of cave in on themselves a little bit. So this first shape, this looks like a pentagon here, five-sided shape. This would be what we would call a convex pentagon or five-sided shape. Because if I extend each side, if I draw lines on each side like this, notice how if I trace each side, those sides do not cave in or go inside the shape. Whereas on this other sort of diamondy looking shape over here, we have some caving in happening. So this shape is concave. If I extend some sides here, you'll see that my extended sides cave into the shape. See that? That red line went inside the shape. That's a concave polygon. Many of the polygons we're going to work with are these convex type. Now, there's something called regular polygons as well. So let's remember that word regular means it has all congruent sides and congruent angles. So it's basically equilateral, which means all the sides are the same, and equiangular. Notice in this picture over here, all the sides have the same marking on them, one little slash, and all the angles are marked equal as well. This is a regular polygon. We're going to spend quite a bit of our time finding areas of regular polygons, whether they're hexagons, octagons, pentagons, whatever it may be. And so it's important to understand the idea of what it means to be regular, okay? Also, let's take a look at angles inside some shapes. So you have this in a chart sort of format in your notes. You have first a picture of a triangle. A triangle has three sides and also three angles. Oops, sides. Okay, it's three-sided shape. And do you remember how many total degrees there were in a triangle? Hopefully, yes. The total is 180 degrees. Underneath my picture of my triangle, you see a quadrilateral. That has four sides. And how many degrees are there in every quadrilateral that we're working with here, or every convex or concave quadrilateral? Or convex, I'm sorry. Every convex quadrilateral, we are talking about how many total degrees there are in the shape. So let's draw a diagonal through there. See that four-sided shape? Now is split into two triangles, and each of those triangles has 180 degrees. So I split a four-sided shape into two triangles, each one having 180 degrees at their vertices there. So a four-sided shape will have a total of 360 degrees. But what happens when we go beyond our traditional three-sided or four-sided shapes? Let's look at a five-sided shape here, a pentagon. Now, a five-sided shape, we can do the same idea. I'm going to start drawing in diagonals here, corner to corner, starting at one vertex here. See how I split that five-sided shape into three triangles? So five-sided was split into three triangles, each one having 180 degrees. So if I take 180 times 3 here, you guys, that's going to tell me how many total degrees there are in a five-sided shape or a pentagon. Total, 540 degrees. And if we continue doing the same thing with hexagon, corner to corner, corner to corner, corner to corner. Look, a six-sided shape, 6 sides, was made into 4 triangles, And each one is 180 degrees. 180 times 4 means the total number of degrees in this shape will be 720. Now we could continue this on. A heptagon is a seven-sided shape, and you can go ahead and continue doing this in your notes. But a heptagon has 7 sides. An octagon has 8 sides. Okay, a 9-sided shape is called a nonagon, and he looks like this. Decagon has 10 sides, and a dodecagon has 12 sides. Yep, we skipped 11, okay? So these are the pictures for those each little shape there, are those shapes that we're talking about, and how many total degrees are in them. Hopefully you noticed a pattern. On the number of sides, if I had a 6-sided shape, it made 4 triangles. If I had a 5-sided shape, it made 3 triangles. And each triangle is 180 degrees. So if we kept this pattern going, we would hopefully understand how to figure out each angle inside a shape, okay? So this is something you need to get in your notes. The polygon interior angles theorem. Polygon interior angles theorem. This says that the sum of the interior angles of a convex polygon with n sides is, so I can find the total no matter what by doing this formula. So I'm going to put total equals, so the total number of degrees equals n minus 2, that's the number of sides minus 2, then take that number times 180. Because n minus 2 tells me how many triangles I would make, and 180 degrees for each triangle. Now, if the shape was regular, okay, each interior angle can then be calculated as well. So make sure this is in your notes as well. Each interior angle, each individual angle, so not just the total like this, but each one individually in a regular shape can be found by taking the total and dividing it by the number of angles. So I'm going to put this as each angle equals number of sides minus 2 times 180, that's the top, all divided by the number of sides. So we can use these formulas to calculate angles and shapes, okay, and to figure out missing angles as they would be labeled in shapes. So let's take a look at this problem. Get this one in your notes. What is the sum of the interior angles of a convex dodecagon? So what is the total of the inside angles of a convex dodecagon? So how many sides does a dodecagon have? That has 12 sides. And so if I was going to find the total, I'd use the formula that says the total equals the number of sides minus 2 times 180. That's the formula you just got done writing down. So if I use my mental math or my calculator here, 12 minus 2 is 10 times 180 means that I would have 1,800 total degrees. Now you might be thinking, wow, that's a lot of degrees. Well, remember, it's a dodecagon. It has 12 sides and 12 angles, so of course there's going to be a lot of degrees there. Let's do the second example. If the sum of the interior angles of a polygon is 2,340 degrees, then how many sides does it have? So let's use that formula again. The formula says total equals number of sides minus 2 times 180. Well, we know the total this time, you guys. We know it's 2,340 degrees. And I don't know the n. So now I need to solve for it. And this is going to take some algebra skills, okay? So think about this times 180 right here. What could we do to undo multiplying by 180 so we can start getting that n alone? Well, we could divide by 180. So if I divide by 180 on both sides, the 180s would cancel here. I'd have n minus 2. And then 2,340 divided by 180 is 13. Now notice the n is not alone yet. I need to add 2. N is 15. So the number of sides would be 15. If we had to have that many total of degrees, that's how many sides it would have. All right, so what if we have a picture like this one? Find the measure of the missing angle. Well, if we take a peek at this, these are all interior angles, and let's figure out how many sides this thing has. 1, 2, 3, 4, 5. That's a five-sided shape. They're not all the same, so I'll erase my little slash marks, but they help me when I count. So this is a five-sided shape. So if it has 5 sides, how many total degrees must it have? Well, let's use that formula. 5 minus 2 times 180. That'd be 3 times 180 is 540, total degrees. So I need to have 540 total degrees in this shape. Well, let's take a look at what I have here. So I have 110, 92, 84, x, 100. That means all of these have to add together to make 540. So I could say 110 plus 92 plus 84 plus x plus 100 has to add up to make 540 total degrees. Now if I add or combine like terms on that side of all of my numbers here, 110 plus 92 plus 84 and then plus 100, that'd be 386 plus x equals 540. And then I know what I got to do. I got to subtract that 386. So I take 540 minus 386, and I end up with x equals 154 missing degrees. Okay, 154 degrees for that missing angle right there. So you need to know the total before you know how you can solve for x. Now let's take a little look at some exterior angles. So there are angles inside a shape, and then there are angles outside of a shape. So exterior angles are located on the exterior of the shape. Exterior of the shape. So these are the ones, exterior means outside. So these are the ones you don't typically see. So if I was going to extend a side here, this one right here would be an exterior angle, okay? And the same thing on the other side. If I extend the side over here, this is an exterior angle. So if I wanted to keep extending sides here, exterior, 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 okay? So for each interior angle, there's also an exterior angle. So other formulas we should add inside of our notes here. The sum for the exterior angles of a convex shape. The exterior angles, the total of the exterior, will always equal 360 degrees, no matter how many sides that shape has. 360 all the time. So that means if it's regular, if I want to find out what each angle is, then I would say each angle equals 360 divided by however many there are. Okay, so exterior angles are a little bit less complicated than interior angles. They have to always have a total of 360 no matter how many sides. And then we can just divide to find each missing one if we're talking about a regular shape. So let's take a look here at an exterior angle problem. This is a four-sided shape, but see how those little arrows extending show exterior angles. We must remember that the exterior angles always add up to make 360 degrees. So the exterior equals 360 no matter what. So what I would do is I would take these and add them and set them equal to 360. So x plus 20 is my first angle here, plus 112 here, plus 96 here, and then plus the other x have to add together to make 360 degrees. So now if I were to combine like terms, notice I have two x's this time, and I have a 20 plus a 112 plus a 96, and that's 228 equals 360 degrees, and now I can solve minus 228 minus 228. 2x equals, let me do the calculations here, 132, and then divide by 2 to find my final answer of 66. So x equals 66 degrees. Very nice. Does that mean that each angle up here is 66 degrees? 66 is right here. And if I plugged in the 66 right here, that would tell me that I actually have an 86-degree angle out there. So exterior angles will always have that 360-degree total. All right, thank you for taking good notes, ladies and gentlemen. We're going to continue on with working with shapes and different types of polygons in days to come.